Okay, so this is my review for exam one for what are we? Spring semester? I think so. There's snow outside. Spring semester of 2020. That's too many 20s. Anyway, this is the exam taken right out of the my files that was given to my students last semester. Um, there are a few problems in here that some of the students struggled with. Oh, we got to turn that noise off right at the beginning. We can't be having that stuff. Sorry, that was my phone. I mean, I go days without it making a sound. I miss all kinds of texts and phone calls, and then the one time I don't want it to make noise, it does. Anyway, there were some things that students struggled with on this exam. I have seen the exam that is going to be given next week, and none of those things are on it. Actually, I think the exam for next week is going to be a little too simple. So I may have to go in and make it harder. Oh, no, that's not what my students want here. Okay, so what I do here for the review on this exam is I'll just go through and I will work out this entire exam for you guys. If you have questions, by all means, bring them up. I will answer them as we go, or if you want to wait till the end. On this exam, there were 10 problems. I think, now don't get me wrong and don't yell at me if there's more, but I think there's only 8 on the exam for next week. Um, that just means some of the exam problems are harder and worth more points. Well, supposed to be harder. I think it's going to be an easy test. There's a few problems on there that are identical. I mean, they're nearly identical, except when you get to the end, there's anyway. You'll see next week. Okay, so this is like Skit said, this was the exam in the fall of 2019. And we'll just start right here. So problem number 1, save the time X and Y data defined below to a file called mydata.mat. Then clear the data and reload it. You do not need to submit the file, just have it. Okay, so uh, we did the data is already there. It's already created for us. It's not comments, so we don't have to do anything with the creation. We just have to save it. So we'll do a save, and then we're going to give it the file name that we want, which was mydata.dat. Oh, sorry. If it has a capital D, not that it makes any difference. And then we're going to tell it which files to save. Oh, not my dot. We wanted the .mat. There is a difference, .mat and .dat. If you want, I can go over that. Hey, teach, what is the difference? Okay, I'll tell you the difference. A .dat file you could actually open up in Word or a notepad or anything and see the data that's in that file. A .mat is just a MATLAB data file. It just saves the values, but the only place you can open it that I have found is in MATLAB. It'll reload the values, but not how they're generated. So you'll see here when we save this. Okay, so those are the values that we want to save. And then we're going to clear, and then we're going to load. The file name is mydata.mat. And that should work. Okay, so we're going to look at our workspace over here. We'll clear out our workspace so that you see that there's nothing there right now. So it's empty. So we'll execute this code. Boom, there we go. We have A, B, and time. But, okay, so yeah, see, so that's all it did was saved the values, but not how they were generated. So that's why when you guys turn in a .mat file for grading, I can't grade it because it doesn't show me how the values were obtained. They just shows me the final values. Hopefully that makes sense to somebody. Okay. Find the times expressed as a vector, which corresponds to increasing values of A. So this one here was one of the problems that was kind of students struggled with. Like, I think it's not so much as what had to be done. It's just trying to interpret what is being asked. So basically what we were asking here for is for you to sort the data and give us the times at which one? A. Um, it's sort of from what does it say? It doesn't say of increasing values. So it's going to put the smallest value first, all the way up to the largest value, and then it also wants to report back the time when that value happened. Okay, so if you'll remember back, and this is where students, because we never did this in the homework, not with the sort value, we did this with the max and min. If you assign the output of that function to two variables, too many C's. The second variable will receive the location within the first, within this vector of where these things are located. So this is going to return, and I'll go ahead and display this. So, oh, it's displaying over here. So these are the values in order from smallest to largest, and this is where they're looking at. So the first one was there, the next was in position number 9, and so forth. And now to get the time when those things um, occurred, this is where some of the students, they'll sit there and manipulate that location um, thing, but that's all you have to do is put the location back into the time vector, and it will tell you exactly the time, or in this case, that would be not necessarily a time trig function. I don't know, I guess maybe it could be, but so that's what happened. First one happened at time index 1, then 97, 13, and yada, 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 yada. Okay, so again, you don't have to display all of your working, but I do want to see the final results. Okay, so that was problem number 1. 1, 2, 3, 4, 5 lines, 2 points per line. Hey, that's pretty cool. Yeah, that was pretty cool. Okay, so now we will go to problem number 2, which says plot a single plot with time from above on the x-axis and both A and B on the y-axis, and label them and include legends and titles. Oh, title, MATLAB is awesome. Oh, far out, they're demanding. Oh, okay. So anyway, so because this problem builds off of the first problem, I'm not going to clear the variables in between the problems. This is one of those rare occurrences where you don't want to clear. You can clear them if you want, but then you have to reload them back in, which doesn't make any sense. It seems kind of redundant. So we're going to do plot, and we're going to put time on the x-axis and A on the y-axis, and we're going to do that twice to get 2 plots, time and B. So there's our plot. And then it says to do the X label as time. And I do, oops, it's got to be in the parentheses, you idiot. Hey, don't call me that, it hurts my feelings. And what was our, did it give us the units up here? Units or seconds. So yeah, so you want to get in the habit of including units whenever possible. I lost a lot of points on a lab at the University of Utah in my strengths and materials because I didn't put units on it. But it's there, but I don't know so I lost points. So I've always stressed afterwards to all my students, make sure you put units on your tables and charts. Okay, and then the y-axis is what? What is the y-axis? Where'd my mouse go? There's my mouse. I have no idea what it is, so we'll just.
I think it's down into.
Oh, right there, distance, right there. Yeah, distance and millimetrics. Distance in millimetrics. And then we'll do a legend. And I think these are in square brackets. Are they? Let's see. We'll do A, comma, B, comma. And then what else? Title is MATLAB is Okay. And I think that's it. Okay, so, and then we'll run that, and hopefully we don't get no errors. It's taken a long time to run. This isn't, hello? Oh, there we go. Okay. So obviously I did it right. No, I didn't. Because there should be 2 lines there on the legend. There we go. No square brackets on the legend. So see, yeah, I made a mistake. And it is being recorded, and good thing is that I can edit that out before I post it. Okay, I won't. I'm human. You guys need to know that. Okay, any questions on this problem? Pretty simple. Chapter 4, plotting. Okay, another way you could have done the plot if you didn't want to do this would be to do a plot of time, comma, A, and then hold on, and then plot time, comma, B, and hold off. But yeah, you see that was 4 lines when you could do it in one. That's, to me, that's a lot of extra unneeded typing. So either way is acceptable. It doesn't tell you which way to do it. It just says to do it. Plot a single plot with time. Okay. Okay, problem number 3. Speed data for the last 25 seconds of flight for simulated flight test is provided. Oh, it is? Where is it? Okay, I hope it's in my file. So in order to start this problem, we need to load the data. So column 1 is the time, column 2 is the truth data or true speed, and columns 3 to 5 are 3 different sensors measured at of speed, all in feet per second. Find the minimum true speed and the time it occurred. Okay, so we're going to find the minimum. Oops, not up there. We're not. Sorry. We're going to find it down here. So first thing we need to do is load the data file. There's no S in load. Trust me, I know. I are an engine manure. So simulation underscore data, and I hope it's the right file. And so doing that line of code right there will load this data file into MATLAB's memory and assign it to a variable called simulation data. Okay, to me that's a lot of extra typing, so I'm going to rename it simulation data. So now I can use data. Okay, let's see if it has, what is it supposed to have? 1, 2, 3, 4, 5 columns. Simulation 51 by 5. Okay, cool. So that is probably the right data file. Okay, so now we want to find the minimum true speed, and that is column 2. So we'll go TS is equal to data. I want all the rows from the second column, and time is equal to data, all the rows, first column. Okay, so we want to find the minimum true speed and the time at which it occurred. So we're going to find, assign it to 2 variables of minimum true speed and its location. Oh, when we gotta, and we want min of data. No, we don't. True speed, STS. That's why we extracted that. Okay. Oh, it's already got it cleared up here, so I don't need to do that. Okay. And then the time at in TS equals time and location. And just so we can see what the value was, we'll print it out to the screen. So the time was at 72, and the minimum TS true speed was 900 feet per second. Okay. Did I confuse anybody on that? No? Okay, cool. And then find the value of the 3 sensors when the true speed is at its minimum. Did we do the find values? I don't think we've used the find feature yet. Because I mean, so I just don't think we've covered find yet. I think this was another one of those problems that the students struggled with. Well, how am I supposed to do that? I uh, let's see. Oops. So I think this is one that I didn't. Everybody got full credit for this one because it's something we've never done before. But um, there's a command called find, and you tell it um, what to find. Um, uh, whoa, brain cramp. 'Cause I can't remember which one comes first. Either the um, time at man in TS. Oh no, we want data, all the rows, columns 3 through the end. Oh, here we go. That's okay. I got it now. I got it now. Sorry. I tell you, I wish I was a drinking man so I'd have an excuse. We're going to look in that folder for everything that is less than, or equal to that. There we go. That's the way that thing works. And that's going to be TS. That's how that works. And it was empty. Was there any actual values in that data file? 3 to the end.
I get it, I get it. Oh, shut up. Okay, let me go.
So, yeah, there was none. That's a stupid question. Um, okay, well, like I say, I didn't grade this problem because it was a stupid question. And that's one thing I do, just so you guys are aware. I take the exam because I don't write these. And if I have problems trying to figure out how to do it, like this problem here, I can't expect you guys to do it if I can't. So I don't dock you for something I can't do myself. So I'm sorry if I have shattered your image of me and that I'm not the perfect instructor, but oh, man, I do live in a fantasy world. Okay, problem number 4, 13 points. Kinetic energy is measured the amount of work needed to increase speed of the body from 0 to v and is found by the equation ke equals 1 half mv squared. Ooh, I got a story behind that equation, but we won't go into it. Find the kinetic energy from 3 masses when traveling at the following speeds. You must use mesh grid for full credit. Why do you got to use mesh grid? I'll tell you why you got to use mesh grid, because you have 3 masses and 4 speeds. So these guys here, we're going to borrow these guys so we don't have to write them. Oh, no, you don't. Oh, yes, we did. Let's redo that, and then we'll just take this here and come up here and make it code. I tell you, I am probably the laziest programmer you'll ever find. If I can copy and paste something, I will. And we'll get rid of this kilogram here so that it doesn't cause us an error. Okay, so we got our mass and our velocities, but they're not going to work because they're of different sizes. So we'll use mesh grid and we'll capitalize and put a brackets around it. Mass and velocity is going to equal mesh grid of mass and velocity. So what that does is now we'll create a matrix that is 3 by 4 of these rows and these columns situated such that when we come into and use our equation, say KE is now equal to 0.5 times mass dot times velocity dot raised to the 2. And we'll get us a nice little matrix, and there's the kinetic energy for this given mass, or this given mass and this given velocity. Any questions, comments? That was easy. Okay. Number 5, the quadratic formula uses the a, b, and c from ax squared b plus bx plus c, where a, b, and c are just numbers. They are the numerical coefficients. The formula is derived from the process of completing the squares and is formally stated as an equation you guys are well familiar with. Right, two anomalous functions, one to return a positive square root of the discriminant x pos and one for the negative x neg, given the inputs of a, b, and c. Okay, so if you all remember, this is what the chapter you're working on now is user-defined functions. The anonymous function begins with the name of the function, and then it starts with an ampersand or an at symbol, and then your variables that will be within your equation, and then your equation. So we're going to start with negative b. Where'd my b go? There it is. And so this one is positive, so we're going to add the SQRT of b raised to the 2. I'm just so 4 times a times c, and all of that. See, 1, 2, 3. Okay, so those are my square roots, and then all of that is divided by 2 times a, and we're going to suppress the output. Oh, not double A's, just one A. Close the parentheses, and okay, and then we're going to cheat because this is going to be just that changed and that changed. And so there's our anonymous functions to solve the quadratic equation. Oh, and I put them up there. You guys should have said something. Hey, stupid, put them down there where they belong. For verb and code, and then we'll get rid of these up here. If I was working in an M file, that would have worked, and I could have done it up there too, but the solution's down here. Either where you put them, I'm not going to grade you one way or the other. So use your function to find the roots to the following equations. So x1 is going to be the x pos of a is what? Where to go? Oh, 6 comma -1 comma -35, and x2 is going to equal x negative of, yeah, I could have copied and pasted, I should have, but it's a little late now. And hopefully it works. Yay, I got answers. Woohoo. Okay, extra credit. Verify your answers by plotting the equation for the values of x between -5 and 5. Add red vertical lines at each crossing and a green horizontal line at y0. Okay, so um, we're going to do some plotting here. Yay, plotting. We like plotting. So we're going to do an x, and we're going to run that between -5, and we want a lot of data points, so we got smooth lines, and 5, and we're definitely going to suppress the output. Um, then we'll create, whoa, sorry, my ear itched. Create an equation of 6 times x dot raised to the 2 minus x minus 35. So that was our equation up here, 2x squared, 6x squared minus x minus 35. Okay, and then we'll plot x comma y. And then I guess we could do a title if we spelled it right. Um, X label. Oh, let's get creative here. Let's call it, I don't know, let's say X and Y label. X, oh no, let's go 6x raised to the 2 minus x minus 35. We'll put the equation in there. Okay, so let's, okay, so now we got to do the vertical lines at each crossing and horizontal line at y equals 0. So to do the green line, we'll do it first, horizontal line. Let's do a hold on and then plot our beginning point for our x and our ending point for our x in square brackets. And our y is going to be, we want it at 0, so we'll go start at 0 and end at 0. Okay, hopefully that didn't confuse anybody. And then we're going to do our crossing points. Oh, wait a minute, wait. We got to make this green. I know we got to make it green. Green is, yeah, and let's make it a dashed line. Dashed line. Let's see what that does. Okay, and then we have our x with x1 and x1. Oh, and then so it'll go. So it plots to the top and bottom on our limits, and then these were supposed to be what? Red, red, red. And then the other one, again, this because this was extra credit, I didn't, if you did it, you got it, but I don't think we ever did anything in there with plotting vertical lines like that in the homework. So many freaking Oh yeah. Oh yeah. And then we'll do this one red. And we can play with the format on the lines afterwards. Okay, we're going to cross our fingers and hope it doesn't explode on us. There we go. Is that cool or what? Say, yeah, that's cool. So these red lines, like say at x1 is right here at minus 2 point, and it looks like it crosses at the 0, and that one crosses at the 0. So that verifies that these numbers are correct. Again, if you're doing a vertical line, you just do the same spot on your X, starting top and bottom, and then Y limit goes from top to bottom of your plot. Okay, okay. We still got 4 problems to go, and we're 30 minutes into this. Okay, ooh, this is a big one. 20 points. Any questions? Okay, I'm going to go on. Define x from negative 20 to 20 in steps of 1. Okay, so we're going to come down here, and x equals 20 by 1 by 20, and we didn't need to put the 1 because, oh, no, do negative, otherwise you're only going to have 1 point. There we go. Okay, define y minus 15 to 15 and half. Okay, so y equals minus 15 by 0.5 to 15. And see, this one's kind of the redundant of the last one. We're building 2 vectors, and then we're going to mesh them together to create new matrices and then create an equation. We're going to borrow this so we don't have to type it out again. Boom. And we're going to, and if in the mesh grid, if you use the same variable names, it will still work. It'll just overwrite the original values with the new values. The reason I'm doing that instead of creating new ones is because I don't want to have to go through here and change all those numbers too. I'm being lazy. Y comma x, and we're going to suppress that output, otherwise we have a big display of numbers. Okay, so everything is dot multiplied, dot raised, plus divided by, okay, so that equation should work. Cool, that was easy. Okay, oh, subplots. So on one figure, create 2 subplots. Okay, so come down here and we're going to do subplots. So, okay, so subplots takes 3 inputs. The first one tells how many rows. I'm going to do, it doesn't say, does it say whether to do them rows or columns? It doesn't. So let's do 2 rows and 1 column. And then the third number tells you which plot to use, starting in the first column, and then it goes across. So cross. Once you get to the end of the first row, it drops down to the next row and goes across all the columns. Now, because we only have 1 column, it'll just drop down to do the next plot. Okay, so on the first plot, create a surface plot of the data X, Y, and Z. Okay, so we are going to do a surf plot, and we learned in chapter 4 that that is surf, and we're going to use X comma Y comma Z. And what else does it say to do? Add appropriate labels and titles. Okay, so we'll title this one and then, oh, this is bad because now you got 3 labels to, X label is X. And what's sad is it defaults to X, Y, and Z if you don't do the labels, but we're going to do that just to show that we know how to do it. Y, comma, and then Z label is Z. And you're an idiot. No, I am. Thank you for noticing. Okay. So, add the color bar. Here's how type color bar. Okay, so it tells you how to do that. Type. Um, and let's see here, shading to interpolated. So, okay. And then in the second subplot, create a pseudo color plot. Okay, so let's call up our second plot. So now we're going to do subplot. And again, we had 2 rows, 1 column, and this will be the second one. And then it tells us up here to use P color XYZ. Again, I don't remember us using that problem in the homework, but it made it to the exam. Okay, shading to interp, add color bar, labels, titles. Okay, so we're just going to borrow all this stuff right here and bring it down here. That was lazy. Yeah, except the title is going to. Did we do? Oh, we didn't bring down the title. Let's, and this is. What was this? It was a pseudo color plot. A pseudo. I hope I spelled that right. I didn't spell it. I are an engine manure, not an English major, so sorry. Okay, so let's see what happens if we hit that. Does it work? Function. Okay, yeah, we don't want to, but okay, but it gives us what we want. I think, I don't know why it called up all that. I wonder if we just get rid of that. Yeah, that's where we go. Here we go. Wow, isn't that pretty? So yeah, that's pretty. Hey, that's pretty. Okay. B on another. Create 2 subplots. On the first mesh grid, the second create a combined surface with columns, contours, labors, for fun. I can play around with rotating CDs. Okay. So again, here we're going to cheat. We've already done all this typing. And we'll just bring it down here and change the types of plots. First one is a mesh plot. So we'll change the surf to a mesh. And mesh plot. And then this one here was a surface C. I think there was something like this in the homework. Oh, there we go. Okay. Oh, call up a new figure here so that it doesn't overwrite our first one. And then you come in here and play with this one, rotate it around, and look at it and say, ooh, wow, that's neat. Okay. So that was that problem. That one wasn't really hard, just a lot of tedious typing, copy and paste. Okay, problem number 7. Consider that you are creating a mathematical model used to, in a simulation, predict the performance of the latest widget you are designing. Oh, we're back to the widgets. One of the parameters that needs to be varied in the studies is wind, both speed and direction. For wind speed, let us assume that a normal Gaussian distribution with a mean of 20 ktas, kilotons, and a 1 sigma value of 3 ktas is a good approximation of where you'll be using your widget. For wind direction, let us assume that it is likely for it to be blowing in any direction as another, so we should use a uniform random distribution between 180 minus 180 degrees. Create a table called wind with 2 columns. Oh, look at that. They already did that for us. Um, with 2 columns, data 20 random. Below is how I want the results, not due to random. Okay, also now we got to create our own. Oh, how silly is that? Okay, so this requires you to remember back into the random numbers generator. So we're going to have a wind speed is going to be equal to, so now we have the wind speed was, for wind speed, a normal Gaussian distribution. So that would be a rand n, and we want 20, 20, 20 random numbers. So we'll have 20, and it's going to be multiplied by the sigma value of 3 and plus the mean of 20. So that was taken off of the mean of 20 here and the sigma value of 3. So there's our wind speed. And then we want to do our wind direction. Wind direction is equal to, and then this one is wind direction. Let us assume also we use a uniform random distribution. So that one's just a normal rand. And again, we want 20 values. And so we're going 360 degrees minus 180. And then we're creating a table. Wind is equal to our 2 values of wind speed, and we'll put next to it the wind direction. And hopefully they come out in the right columns and not vectors or rows. So there we have plus or minus 180, and so the hardest part of this one is just remembering all of your random number generators, what you plug in where in order to beat the criteria listed. Okay. Anybody still awake, or did we all fall asleep? I know I did about problem number 2. Okay, on to the next one. Rectangular ducts. Rectangular ducts can be approximated as circular pipes in some equations by using what is known as the hydraulic diameter. DH equals 4A divided by P, where DH is the hydraulic diameter, A is the area of the rectangle, and P is the perimeter of the rectangle. create a function. Oh, goody, we get to, oh, this is the last problem too. I thought there was 10 problems. Oh, there's 10 points, 8 problems. Okay, cool. So this is the last problem. Yay. Create a function called hydraulic that calculates and returns the hydraulic diameter based on the two inputs, the width and the height of a rectangular duct, and returns the hydraulic diameter. Put the function at the end of this test. Do not create a new M file for it. And that works for both the live editor and an M file. Oh, and I didn't show you how to do that. We'll have to redo that and start over and show you. Okay, finish the test, then get in the, okay, I will, sorry. Okay, so we're going to create a function. So to do a function, the first thing we type in is the word function, and then we give it the return variable. Can be anything you want to call it. I usually call it results, because that tells me that everything's the results is what I'm going to pass back to the function, or not function, back to the main script file. Again, it's what you can call it calfragilisticexpialidocious if you want, but that is a lot of letters to type. And then it's followed by the function name and the input variables. And in this case, we are inputting A and P. Now you'll notice that here it automatically kicked up an end for you, so you don't have to remember to add one. But when you are writing inside of a script file, if your functions are at the end of the script file, they must end with an end. If you're doing a separate in a separate M file, I don't think you have to have an end, but put it in there anyway. Better to be sorry than safe. I mean, safe than sorry. Okay, so what do we got? So we got our result is equal to, and where did our equation go? I lost it. There it is. 4 times A, and we're going to do a dot divide by P in case somebody tries to slip in a vector. I always try to make my functions usable for any input. Although technically, if we want to make this for any input, we should do a mesh grid in case you bring in two vectors of different sizes. So we can do A and P is equal to, mesh grid of A and P. And now we are safe for any input. This would not be required for the test because it didn't tell you to do that. And then we're going to come up here and test our hydraulic function with A and P passed to it. Well, A and P has no, I'll get to it. Oh, so we got to do some calculating before we can do that because it just gives us the diameter or the width and height. So A is the area of a rectangle. Let's height is equal to 8. Width is equal to 12. So our area is equal to the height times the width. And the perimeter is equal to 2 times the width plus 2 times the height. And then we'll test it. Boom, 9.6. And that's it. Any questions? Okay, so when you receive this exam at the testing center, obviously I won't have the answers into it. So let's save this, and I will post this file on that same or on Canvas so you have it in case you want it. I don't know why you'd want it. You can watch the video and create your own. Okay, so now let's come in here. This is what you're going to get at the testing center. They'll give it to you on flash drive. You'll bring it in. copy it to your computer, or they may have you work it on a flash drive. I'm not sure. I forget how it is. But remember to save often. Save often. Um, if because if and I think you do want to save it on the thumb drive if they allow it, because if you save it on a computer and a computer goes down for any reason, when it boots back up, it wipes the hard drive clean and you lose everything. So set your um, current directory to the thumb drive if this is the way. Set the current directory. You click on this button over here and then navigate to wherever the current directory will be, and that's where your program file. But let's say that you are very uncomfortable working with the live editor. Okay, I like the live editor for tests because I can go through and I can run your code, and when I return back your test to you, you can see exactly the results I get when I grade your exam. Um, anyway, but if you don't like live editor, uh, if you just come over here inside of this exam and do a export, no, save as, or is it up in here? Here we go. Uh, 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 um, where is it? Okay, maybe it is a save as. Change it to an M file right here, MATLAB code, and then that'll open it up in the standard M file format. And again, even in this format, you can come down here and create your functions if you spell it right. Um, hey, somebody left. I bored you so bad you left me. Or is that somebody just joined in? Oh, somebody left. Alex left me. He got bored. Um, A comma P um, equals 4 times A divided by P and and um, and you see it will run. So you can put your functions inside of an M file at the bottom. They have to be at the bottom of the file and they have to end with an and, and it will work. So that's what you can do if you don't like Live Editor. You can create your own and turn that in. I will once if you turn in an M file, I will just open it up as a Live Editor, and I'll get everything that you did in Live Editor form. The test is in the testing center beginning Monday morning, and I believe it goes through Friday. Take it whenever you can. Homework for anything prior to this exam is due no later than midnight on Friday. I will not accept anything after Friday. I can't. It's department policy that once the test is done, I can't accept any homework. You have 2 hours, no notes, no homework. You will be given an e-reader at the testing center of the textbook. There is also the live help on uh, MATLAB here. You just type in help and then whichever command you want help with, and it'll pull up. And give you some help, and if that isn't enough, you can come down, hit documentation for, and that'll open up even more help. You can use these. I think I allowed a calculator and scratch paper. Scratch paper will be gathered up at the end of the exam. You must schedule beforehand to go and take the exam. Oh, yeah. I think that's about the size of it. Anybody got any questions, comments, wants, needs, desires, concerns, complaints?
I'm good.
So was that useful or did I just waste an hour of your time?